Hey guys, welcome back. So let's discuss more about heaps today. So one thing that you should all know is that heaps are complete binary trees. So when I say complete binary trees, it means that suppose you have a max heap like this. So this is a complete binary tree, which means that you have all of the levels completely filled except the last. So suppose um, so this is a complete binary tree, and all the levels are filled except the last. This is also a complete binary tree. This is a complete binary because all the levels are filled except the last. But here, this this won't be a complete binary tree because this the second last level is not filled in. All right, so this is not a complete binary, while this here is a complete binary tree. So you understand all the levels should be completely filled except the last. That's called a complete binary tree. And heaps are complete binary trees. All right, and more things about heaps is that in a max heap, suppose in this one, in a max heap, you will, if you want to find the maximum element, you can just take out the top element. So it provides O1 lookup of the max element in max heaps, and similarly O1 lookup of minimum element in a min heap. And if you want to insert an element or delete an element, they both will take log of n times. And this I will show you in a minute of how to basically insert or delete an element. But as I said earlier, these are not asked in interviews usually, but these are some things that you could know because the interview may just start discussing about these, but you will never be asked to code these implementations. All right, so let's look at how to insert an element in a heap. Suppose you have a max heap like this. And then you want to insert an element 2. So basically what you do is, suppose you want to insert an element, let's say not 2, this will be really easy, you can just insert it at the end. Let's say you want to insert an element 11. So what you do is always insert at the end, and then you propagate. When I say propagate, I mean that you check if the element that you inserted is greater than or lesser than its parent. If it's greater than its parent, then you swap those nodes. So this 11 is greater than 10, so you swap them. So this becomes 10, this becomes 11, and this becomes 10. And you continue to do this as long as the parent is greater than its node. So right here we have 11 and 12. This satisfies the condition, but like suppose you would have this as 10 again. Let me give a good example. Suppose you would have it like suppose we had something like 9 and then 8 and 7, and you inserted 11, so you swap these. 8 comes here and 11 comes there, so 11 comes here, 8 comes here, and then you continue to propagate because its parent is greater. So now 11 will come here and 9 will come here, so 9 and 11, and now you see that the parent is greater. You do not swap, you don't do anything, and this helps you insert the element in log of n time. All right, and suppose you want to delete an element. Let's take another example, something similar. So suppose you want to delete the topmost element 17, or basically suppose you have like 2 here and you want to delete this 2. So while deleting, what we do is we always delete the last element, but we do not have to delete 2, we have to delete 17. So we first swap these elements 17 and 2. So right here at the top we will get 2, and this last element which was supposed to be 17, we deleted that. Now we have successfully deleted the element, but this is not a max heap right now because 2 is not the maximum element and it is at the root node. So now what we do is something called heapify. So in heapify, we basically check the node, its left element and its right element. we check, basically find the maximum element among the three, all right, among the node left and right. So whichever is the maximum element, we swap those two. We swap the node with that maximum element. So here we have 16 as the maximum element. We'll swap 2 and 16. So this will become 2 and this will become 16. All right, and we continue to do this as long as this node is like lesser than its left and right nodes. So we see that 2 is lesser than its left and right nodes, or like left or right node. So we again find the maximum here, which is 13 in this case. We basically swap the maximum element with the node. So this becomes 2 and this would become 13. Now this 2 is the last element, and it's basically there's nothing to compare in the left and right. So here we satisfy our heapify condition, and this is finally a max heap where we deleted one node. All right, so this would also take O of log n time. And I will be providing the implementations of both of these, basically all of these: insert, delete, heapify, and propagate. I will basically provide the pseudocode so that you can look at it and understand at your convenience, but you will never be asked to code them. All right, but it's good that you understand and can explain it confidently to your interviewer. Also, one more thing I wanted to tell you guys is that heaps are mostly stored in the forms of arrays. So suppose you have a heap here, they can be stored and accessed through an array, something like this. So we have all right, so we have like 6, 1, 2, 3, 4, 5, 6, 7. We have 7 digits here. So everything will be stored according to the level. So at the top 17, then according to the level, then 16, then 14, then this level 13, 12, 7, and 6. Now the benefit of this is that whenever you know the parent node, you know some node, and you want to find its left node, the left child, left of any element x will be equal to 2 times x plus 1 always, and right of x will be equal to 2 times x plus 2. And you can also find the parent of a particular node. So that will be parent of x is equal to x minus 1 divided by 2. So let's look here. Take an example. Suppose you have 14, you want to find its left element. So you see 14, right? So it's at the index 0, 1, 2. So 14 is at the index 2. You want to find the left element. So 2 into 2, 4 plus 1, 5. Its left element will be 7. See, it's 7. Similarly for the right one, 2 times 2 plus 2 will be 6. And similarly, it's 6 here. If you want to find the parent of, say, 14 only, so that will be 2 minus 1 divided by 2. 2 minus 1 equal to 1 divided by 2. And the fraction will be ignored. So like 1 by 2 will equal to 0.5, and this will be ignored and become 0. So it will be at the 0 index, which is 17. All right, so that's a good way to know about the parents in the left or the right element, and that's how we can basically use the heapify and the propagate function to insert and delete elements. Look at the pseudocodes of these and you will get a much better understanding, and I will also be providing a question so that you can solve it and look at the solution of it. All right, thank you for joining and see you in the next one.